Welcome to module 4 of database management systems. In the last two modules, we have introduced the basic notions of DBMSs. In this module and the next, we make an introduction to the relational model, which we said is a major data model that we are going to use. So, this is what we did in the last module, and in the current one our objective will be to understand key concepts of relational model, that is attributes and their types, the basic mathematical structure of instance, schema and what is known as keys, and to familiarize with different types of relational query languages. This is the module outline that we will follow. So, we again repeat this example from past. This is an example of instructors in a university, a table of instructors given by attributes or columns, ID, name, department name and salary. These are the 4 columns, the 4 IDs, and multiple rows which are specific rows, or we often refer to them as tuples. So, you can say that since there are 4 attributes, that is every row has 4 columns. So, this is a 4 tuple that we have, and such a table is called a relation, is as simple as that. So, this is it. Whenever we talk about a relation, we have a number of fields, number of attributes, number of columns, whatever way we say, of a table, and that table according to those columns it has multiple 0, 1 or any number of rows of values filled in, and that is what is a relation. Now, so let us look at attributes more specifically. So, attributes, each column is an attribute, as we said. Every attribute has a domain. The domain is a set of possible values that an attribute can take. So, if you just look into the example here, so I am trying to define a table having different students. So, there is a roll number for a student, there is a first name, last name, the date of birth DOB, the passport number, the Aadhaar card number, the department to which the student belongs, and so on. So, let us say these 1, 2, 3, 4, 5, 6, 7 are the different attributes. Now, if you look into every attribute, then every attribute has a set of possible values, of which some value is entered in a particular row. For example, the roll number is an alphanumeric string, as you can see, it has numerics as well as it has letters, whereas the first name or the last name are simple alpha strings. In fact, we can also say that the roll number actually is not only alphanumeric, it has a fixed length. It has a length of, here is a length of 9. So, you can say alphanumeric string of length 9 are eligible for being values of this domain. There could be more restrictions, but the domain will be certain collection of values which are possible as values of that attribute. When you talk about DOB, that certainly has to be a date. So, it is written in the form of DD MMM YYYY, that is 2-digit date, 3-letter month code and 4-digit year. The passport number is a string, a letter followed by 7 digits, the Aadhaar number is a 12-digit number, the department is a alpha string, and so on. So, the domain is a set corresponding to an attribute which define that all possible values that attribute can take. Okay. Now, these attribute values, if you look at, they are atomic in nature, that is, you cannot divide them into smaller parts. So, what I mean is, say when we are talking about date of birth, the whole date of birth type, the date type is one atomic value. For example, if you were to code this in C, what you could do? You could possibly create a structure with 3 fields, one is the date, one is the month, one is the year and you will say that this composite record, composite structure is actually my date. You can do a alias type def, you can do, if you are working in C++, you will define a class called date which has these components and as well as operations with them, but that kind of types are not allowed in a relational database. It has to be an atomic type. So, a relational database will give you an atomic type called date, where all of these are pre-specified and has to be taken as one unit. Other atomic types are integer, like we do not have an integer field here. There are strings, there are numerical values which are kind of floating point values and so on. Now, some attribute may have a special value called the null value, which is the member of its domain. Actually, every attribute of any domain can have this special value. The null value is not actually a value, it is actually an absence of a value. So, it says that this value is not known. So, if you look into the example above, then you will see that for passport we have said that the passport is a string letter followed by 7 digits and it is nullable, which means that in the passport field I may have a value, may have this null value, which means that it is not that the passport is null. What it is saying is that this passport number for this particular student, the row number 2, is not known, is unknown. Now, all fields may or may not be nullable. For example, we will not allow DOB to be nullable, date of birth has to be there. We will not allow roll number to be nullable, we will not allow first name to be nullable, but we may allow last name to be nullable. It has been a style of let not to use your last name. Many people just use one name. So, you could allow that it is not known, it is not there. Whereas, department may not be nullable, it must be there. So, null is a very critical concept, and what it actually does, it actually creates a lot of issues and complications in terms of defining many operations. So, understanding null as a value in terms of an attribute is a critical requirement for the design. Now, coming to the schema and instance, we have discussed about the basic understanding of schema and instance. So, understanding them formally now, we say that if we have a schema, so it is like a table having multiple columns, say there are n columns having names A1 to AN, then this A1 to AN are the attributes. So, these are the different attributes that it will have. So, these are the different attributes. So, if I have this, then it basically means that I have a table where these are the columns A1, A2, AN like this. Okay. So, then a relational schema is a collection of these attributes. So, it is a collection of all these attributes. So, we say R is a relational schema which has attributes A1 to AN. Now, every attribute AI has a domain DI. So, for every attribute I have a set of values that are possible. So, if you recall, then here we had different these are the different attributes and these are their different domains. So, DOB is an attribute and the domain is date. So, any possible date. Aadhaar is an attribute and this is the domain, which is a. So, all attributes, each attribute will need to have certain domain and those are marked by the D sets. So, we will say that a particular relation R. So, R is a schema. So, a particular relation R is a subset of D1 cross D2 cross dot 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 Dn. So, recall the mathematical notion of relation, which say that a relation is basically a subset of a set. So, these are the possible values. So, the first attribute can take values from D 1, second attribute can take values from D 2 and so on, and the nth attribute can take values from D n. So, any specific row, any specific record is a set of values for A 1, A 2, A n, and therefore, is a member of this Cartesian product, and the relation is a subset of that. So, this is every value is an n tuple, which is a subset of this A 1, A 2, A n. This particular record is an element of this Cartesian product set, and R necessarily is a set of such tuples. That is a mathematical view of the schema and the instance. So, this is the schema and this is the instance corresponding to that schema based on the different domains of the different attributes. And this is the notion that we will continue using. So, please try to follow this carefully. Now, whenever we have an instance, we mark that as a table, and every such table. So, here you have now understood it very well. So, these are my attributes. So, this is A 1, this is A 2, this is A 3, this is A 4, and any one I name, these are the different values A 2, A 3, A 1, A 2, A 3, A 4, 9, 8, 3, 4, 5 is A 1, Kim is A 2 and so on. Now, naturally this it is not visible from the instance, because we are taking an instance view. We are not being able to see what that domain is. That will be visible if we look at the corresponding DDL, the definition language description of the schema, which must have specified ID as a numeric value, the name as a string value, the department name as another string value, whereas salary as a numeric value and so on. Now, what is important to note here is a relation necessarily is a set, as we said, is a set which is the relation R is a set. This is a set which is a subset of this set. So, a set, we know the elements in a set are do not have any ordering, they are unordered. So, a relation is necessarily unordered. So, it does not really matter that in terms of this collection of rows, which row is at what position. If I reorder them, the relation does not change. It is just that they are a collection of this set of rows. So, that lack of ordering is a critical information that we will have to remember in mind. Next concept is key. So, R, as we have seen, is a relational schema, which is a collection of attributes A 1, A 2, A n. Now, K, let K be a subset of R. So, it is one or more attributes. It has to be a non-empty subset. Now, we will say that K is a super key of R if we consider the values of different tuples in the attributes of K, and we find that there cannot be two tuples which are different, but match on these attributes, which mean that the values of the attributes of K uniquely identify each row of the relation. Then we will say that K is a super key of R. So, the instructor table that we have seen, ID is a super key. Similarly, So, K can be taken as a singleton set of attribute ID, or K can be thought of as the set comprising ID and name. Both of them are super keys of instructor. Now, we say a super key K is a candidate key if K is minimal. So, the idea is like this, that this is a key, super key, this is also a super key, but certainly this is a subset of this is smaller than this. So, we will say this is a candidate key, but this is not a candidate key, because it does not satisfy the minimality condition. There could be multiple candidate key in a relation. If there are multiple candidates key, then we select one to be the primary key. Now, obviously, there is a question of which one we select, but any one can be selected as a primary key, which is the key of the relation. And we will see that in some cases there is concept of surrogate keys. So, if I have a relation where there is no attribute whose value can uniquely identify each and every row of the table, then I might synthetically generate a value. For example, like a serial number, I can generate a serial number and say that this is my value. So, that serial number or that computer generated field value has no business implication, because the real world did not have this value. It is not like a Aadhaar card number or like a passport number, but it is a value which is purely generated to identify every row uniquely. So, such keys are known as surrogate keys or synthetic keys. Now, let us look at some examples. This is again the same student database I just shown a while ago, the same set of columns, but I have added few more rows. Now, if we look at what could be a super key, there are several candidates, but I have just written a few. Roll number is certainly a key, because I am assuming that the university assigns roll numbers to uniquely identify every student. So, there cannot be two rows in this table which match in the value of the roll number and does not match in the values of the other fields. So, roll number can uniquely identify. If it can, then any superset of attributes which contain roll number will also be a super key. So, roll number and date of birth together is a super key that can also uniquely identify every row, trivial. What are the candidate keys? Now, there are, of course, there could be several other super keys, that has to be kept in mind. The candidate keys are, roll number is a candidate key. The first name, last name together we can say is a candidate key. So, we are saying that not only the first name, but if we take this pair, you remember the K, the set of attributes forming a super key is a set, it is not an individual field. So, I can say the first name, last name together forms a key. Well, this does make some assumption, because if I say the first name, last name together forms a key, that means that there cannot be two records in this student table where the first name and last name match, but the records are different. So, which mean that no two students having the same first name and last name can be enrolled in the university. This is a restrictive assumption, right? But I am just making that assumption to illustrate the different possibilities. Then what is the other possibility? Passport number, everybody has a unique passport number. So, passport number would also be a key, could be a candidate key. Aadhaar number, everybody has a unique Aadhaar number. So, that can be a key, and so on. So, these are called the candidate keys. Now, of course, we can observe that given the data it is clear, and it was also mentioned when the schema was designed, this passport number cannot be a key. Why can it not be a key? Can two students have different Same passport number? Of course not. Every student has a unique passport number. But it is possible that some student does not have a passport. So, if some student does not have a passport, then the passport number field of that student is a null. The passport number is a nullable field. If the passport number is null, then it is possible that multiple students may not have passports. So, as we can see here, this student Jatin Chopra does not have a passport. So, similarly Dipti Datta does not have a passport either. So, certainly if this were to be the key, then for all records for which passport number is nil, this value would not be able to distinguish them in terms of the rows of the table. So, we have to say that passport number cannot be a key, or in other words we can say that no key can be a nullable field. No key attribute or a participant to a key attribute could be a nullable field, right. So, this is one observation we have made. So, that clearly also implies that if we say that other number is a valid candidate key, that will mean that for admission to that university having other number would be mandatory. If somebody does not have an other number, that will have to be null, which is not allowed. Okay. So, let us move on. So, one of these candidate keys have to be made the primary keys. Let us say we make roll number the primary key, and since we make roll number the primary key, in the schema we underline the roll number attribute. This would be a common way to show that roll number is a primary key. So, the others that are not taken as a primary key are called the secondary or alternate key. So, first name last name pair could be an alternate key, other number could be an alternate key, and so on. A key is said to be simple if it consists of a single attribute. So, roll number is a simple key, other number is a simple key if it were taken to be primary, but first name last name pair, if we take that to be a primary, that will not be considered a simple key, because it has more than one attribute. Naturally, the other, if you have a simple key, you have other side is a composite key. A composite key is one which has more than one field, such that none of those fields individually can act as a key, but together they can act as a key. So, first name itself cannot be a key, last name itself cannot be a key, but together they can be a key, of course, under the assumption that no two students with the same first name last name are given admission. So, these are the different types of keys that can happen. Let us have some more views with the keys. We extend the schema, and besides the student I introduce two more schema. One is called the courses, which is given by course number, course name, credits, LTP. LTP is number of hours of lectures, tutorials and practicals, and the department. So, these are the different fields, and from the convention already stated, you can figure out that course number is the key, primary key of this relation. I use another schema which is enrollment, which describes which student is attending which course. So, it has a roll number and the course number. So, roll number of the student attending the particular course number, and it also has the instructor ID as to who is teaching that course. Given this, you can see that in the enrollment relationship, I have this pair roll number and course number, which will certainly be the key for enrollment, because if I have two rows in enrollment, how they will be distinguished? They cannot be distinguished by roll number, because a particular student may take multiple courses. So, there will be multiple records having the same roll number, but different course number. The course number by itself cannot be the key, because every course will have multiple students. So, there will be multiple rows having the same course number, but all different roll numbers. But if we take this together, roll number and course number together, then that forms a key. Now, such a key such a key having roll number, the roll number itself is a key of another relation. The course number itself is a key of another relation. So, when we take the keys of other relations to form the key of a relation, then we say that these are foreign keys. So, roll number and course number are foreign keys in student and course. And since from enrollment the student and courses are being referenced, are being referred, so we say enrollment is a referencing relation and students and courses are the referenced relation. And we will often like to also mention as to what is a foreign key of a relational schema, because that will help us understand how the different schemas are interrelated, and we will see that this will come out directly from the notion of entities and relationships of a ER model, of a ER diagram. A key is called to be said to be compound if it consists of more than one attribute to uniquely identify an entity occurrence. So, each attribute which makes up the key is a simple key in its own right. Mind you, there is a subtle, it sounds very similar. We talked about composite key earlier, we are talking about compound key here. The subtlety of the difference is in a composite key, every component attribute is not a simple key by itself, but and the components come from the same table. In a compound key, the components are simple key by their in their own right in some other table and are put together as a compound key in the given table. So, the roll number, course number in the enrollment table is a compound key. So, with this I would request you to spend some time with this relatively elaborated schema compared to what we have done already of the university database. So, every rectangular box shows a relational schema. On top of each in blue is written the name of that relational schema. So, it has a relational schema like courses, the students, the instructors, the departments, the prerequisites, the time slots, the classrooms and so on, the sections and the relationships between them. For example, the relationship is a relationship which relates students with different sections, sections with courses. Teachers is another relationship which relates to instructors with sections. So, it is showing you directly as to how the keys of this, what are the attributes, what are the key attributes, primary key attributes, and also what are the foreign keys that we have in this. For example, in takes, this is a foreign key which is featured here. Course ID, section ID, semester, year are the foreign key part of the takes that exist here. So, please study this schema. We will keep on regularly referring to this schema in future as well. So, this is what we have here. Now, we move on to the relational query language. We will briefly talk about the relational query language. Now, we will have to in this the key thing that we need to understand is the relational query language is somewhat different from the programming languages that you have studied so far, which are procedural in nature. In contrast, the relational query language is non-procedural or declarative in nature. A procedural programming language requires that the programmer tell the computer how to get the output. Given the input, a program is about finding output for a given input, and you write a procedure, the sequence of steps that need to be done, so that given the input you can compute the output. So, you say how that computation has to happen, and the programmer must know that algorithm. In contrast, in declarative programming, you say what you want. You do not say how that needs to be computed, how that will be computed. You may not even know that. You may not even know a single algorithm to compute the output, but you specify what output you need. So, this distinction between how and what of programming differentiates procedural and declarative programming. So, all that you have studied so far in terms of C, C++, Java, Python and all that are procedural programming, where you necessarily have to specify how, you will necessarily have to specify what the algorithm is, but in declarative you just say what you need. So, just a simple pathological example to understand this difference. Suppose we were interested in computing the square root of a number n, assuming n is a positive number. The procedural step could be something like this. Is an algorithm that you guess an x naught, which is a square root, which is close to the root of n, some guess you make, and then you repeatedly refine this estimate by taking the arithmetic mean of the estimate and the quotient of the division of n by this estimate. So, you take a arithmetic mean and find the new estimate and repeat the steps till as long as the difference between the two consecutive estimates is more than a certain value delta. This is a procedural one. You are giving an algorithm. So, given n, following this algorithm we will find the square root. Declaratively you can just say that what is the result I want? I want a result m such that m square equals n. So, you are again asking for the same, you are expecting the same output, but the way you are saying is not an algorithm. You are rather specifying a predicate which must be true in your output. You are saying that the predicate is m square must be n. So, whatever m is, that square of it must equal n. So, this style is known as declarative, whereas the earlier style is known as procedural. All query languages, relational query languages are declarative in nature. We have talked about the pure languages they are all equivalent, we mentioned that earlier also. And also again to remember that none of them are actually Turing equivalent. That means that not all algorithms can be expressed in them, or specifically relational algebra, which we will look at in more depth, and the relational algebra will consist of 6 basic operations, which we will discuss in the next module. So, to sum up, we have introduced the notion of attributes and their types. We have taken an overview of the mathematical structure of the relational model, schema and instance. We would say mathematically they are relations, mathematically they mean a mapping, and we have introduced the very important concept of keys, and in that very specifically what is a primary key as well as what is a foreign key. In the next module, we will discuss about the different operations of relational model, relational algebra.